Hello, my name is Javid Amidi Abraham, and I'm lead systems design for Agritecture Consulting. Thank you all very much for joining us today in our travel-free digital conference series. My guest today is John Leslie from Vertical Farm Systems. They're a company located in Australia that is developing completely turnkey, completely enclosed vertical farming systems that allow users to produce a variety of leafy greens in pretty much any environment you can imagine. I will turn it over to John for his introduction, and today we have a wonderful opportunity to actually see inside of John's farm.
Thank you, David. Yes, Vertical Farm Systems. We've been established now, we're in our 11th year with around 9 years of research and development. During that time, we've been looking at the need for vertical farming, which on a global level is being accelerated because of the increase in population, reducing the amount of arable land per person quite dramatically. We're now down to under 650 square meters of farmland per person on the planet. So the density of farming has to increase to maintain the food supply chain. And also we're seeing parallel with this, that the number of farms is dramatically dropping. In Australia, there are now under 86,000 farmers feeding a population of 25 million people. And we're seeing that trend globally as the cities become larger and the farms are becoming fewer. Parallel with this, in 2017, after 8 years of development in leased facilities, we built our own facility where I am today. And in that, we've installed a demonstration system of our XA series, which is a fully automated climate cell-based system that allows the growing of leafy greens at this time. So we're working now on other crops, protein crops and animal feed crops. This system has a level of automation that allows one person to operate it with 6 hours of labor required in total per week. And that 6 hours in this demonstration system produces 900 pounds of harvest finished product every 7 days.
Wow.
So we're getting 52 harvests a year out of this system. The reliability is extremely good and the quality is exceptional. It's the highest quality of food that would be possible to produce. The methodology we use for this is a system called bioponics, and I'll explain that a little when we do the walk around a little later. It's fundamentally the use of live microbiology in association with organic nutrients to get the maximum plant uptake of minerals with the total absence of any chemical inputs, pesticides or herbicides. And we're seeing the net result in both yield, plant quality and absence of pests and predators is as high as we've been able to see anywhere in the world. Okay, there's our preamble. How's that?
That was great. Thank you. That was really interesting, John. Now, I have a quick question before we get into the farm tour. You mentioned bioponics. Can you elaborate a little bit more on the nutrients that you guys use in order to facilitate this bioponic production?
Yes, certainly. Bioponic production revolves around the use of microbiology. It was originally developed by a US guy called William Texier in the 1970s. By taking the microbes and fungi that were present in healthy farm soils 30, 40 years ago, before the advent of superphosphates, which killed a lot of soil microbiology, we can use those cultured microbes and fungi and colonize our whole growing system. And
Wow.
we do that in a reusable grow medium. The grow medium, as you'll see in a while, has clay pebbles. Each one of them has around 2 million live microbes living within them constantly. And when we put to that a nutrient that is a mix of storm harvested ocean kelp and other organic based nutrients, the microbes digest that, and the exudate from the microbes is a high mineralized source of plant food that in a liquid medium is readily uptaken by the plants.
That's really interesting. So in essence, you guys are taking a lot of the benefits of soil farming and incorporating them into soilless platforms and enhancing soilless growing that way. And the fact that you can do that in a nature where the medium is recycled provides even more advantages on the operational cost of things, where you don't have to keep buying that medium all the time. So I can see how that would provide the user significant advantages over other systems in the market.
Yes, yes. In our earlier work, we used single-use grow media and became immediately aware of the immense waste stream that is generated by single-use media that in Australia at least is now classed as a contaminated waste, and it has a special dumping fee schedule to get rid of that because it contains phosphorus and potassium and all these, so it has to be put into special dumping areas. And we just couldn't see the long-term sustainability of essentially throwing out the farm after every harvest and waiting for the truck to bring a new farm. It wasn't working for us.
Well, that's great to see you guys have considered that in the design process and incorporated designs that allow for the reuse of that medium. That's fantastic, and I think something that's great for the industry.
Thank you.
So we look forward to the farm tour now. Let's cut to that.
All right, so I'll stop the share. And oh, you've got video already, haven't you?
Yep.
All right, let's see where Tyrone's up to. Tyrone, you rock and roll? All good? You've got a bench ready? Okay, all right, we'll go live on this. Here we go. All right, so I'll stay in the picture and you can look over my shoulder. How's that, David?
That's perfect. Yeah, that sounds good. So just a bit for our audience.
Here we are in the system, and at the moment, the noise you're hearing is loading of one of our rolling benches with the grow media. And that's happening here.
Ah, okay. Very interesting.
So there's a bed of grow media, and now the automatic seeder will plant that out, and we'll also water it down with a germination accelerant. So the door is opening to the climate cells. We have 3 climate cells in this system. This is a small demonstrator system. We can go up to 28 cells in a system. Now we're seeding this bench here, and it's getting watered down as it seeds. And it's going into that first climate cell there. If it were not going to that first climate cell, it can pass right through the cell and go to the second one.
Oh, okay.
Now, with this system, we have 8 levels in each climate cell, and obviously temperature and humidity, light, and CO2 monitored and managed. When we take a bench into a cell, It's lifted to the correct height, which I'll show you in a moment when this bench reaches destination, and is pushed into one of these levels. By pushing a bench in, a bench is ejected at the far end, ready for harvest.
Okay.
So to start harvesting, we start planting.
I see. Okay.
You've come into one of our weekly harvests here. And while I've been watching that seeding, a bench has been harvested at the other end. So we'll catch the next one and see one being harvested there. What's happening now is the bench is being emptied. And we'll then drive out of here. All of the roots and stems of the harvested bench are now being taken up to the rotary trommel where they're separated. There they are travelling up there. Another bench is being loaded for pebbles. While that's happening, this bench that just came out is now waiting for a bench block. This is the weight we get every week, where the pebbles are separated out and go back into the bench. The roots and stems go out and are composted.
I see. So that's all waste that's coming out of the system?
Sorry, I couldn't hear you.
That was all like the root matter and other waste that was coming out of the system?
Very loud in here.
Oh, yeah. I would imagine so, yeah.
So that other bench, where did it go? Oh yes, it's gone into level 1. So what will be happening, we'll go down the other end. And what will be happening here is a bench is being ejected. Stick my head in here. Up the top. And that will then be lowered down to here, ready for harvesting.
I see. And that comes out the same time as a seeded tray goes in?
Fairly much. We can accelerate the harvest beyond the seeding so that we can maximize our throughput time. Here comes the bench. Coming down. Break the rules and open the door.
Wow,
So
that looks so lush. Beautiful.
A bench of lettuce. And then we'll see a harvest come out of here.
Well, what kind of lettuce is that?
That's a loose leaf. It's called a crisp eater lettuce, which is a loose leaf oak, I believe.
And how do you guys package that? And through which pathways do you distribute that product to market?
That product at the moment is going out through 2 channels. We're wholesaling in 1.5 kilo bulk cartons with plastic liners. And we're also packaging in 100 gram, I don't know what the ounce equivalent is, 100 gram clamshell packs. Here's our harvest.
For our viewers, that's about 3.75 ounces.
then that harvest is going straight into the cold room. And for sorting and packing.
Wow. So this is truly a no-touch system. You haven't
under here,
touched any of the lettuce.
So yeah, and there's the finish of the harvest of that then. These are the clay pebbles that I was talking about, with the microbes living in them.
Okay.
And yeah, fully reusable. I think they're called LECA, light expanded clay aggregate in the US.
Mm-hmm.
US term. We call them clay pebbles.
That's very interesting. So that's one of the reasons why you're able to do this bioponics, is because of the microbes that have attached themselves onto those clay pebbles. Is that correct?
Right. I'll come out of the noise. So the reason that we can do the bioponics, you were asking?
Yeah, those clay pebbles are kind of they're key to that, right? They provide a home for those microorganisms and that beneficial bacteria to kind of hold on to.
Totally. There is one secret ingredient in the 27 herbs and spices that we use, and that allows the reuse of the clay pebbles. It's a sustainable, natural additive that we use that prevents cation binding, where typically you would see the positives, the iron, calcium, phosphorus binding to the clay and reaching toxic levels. We put an additive in our nutrient that prevents that.
Very interesting.
That is the key to reusability. Yeah.
And about how many cycles can the pebbles be used for before they have to be replaced?
We find that the pebbles mechanically degrade by the way that we're handling them through the rotary sieve, and they're abrading against each other and going back to clay dust. And then they get washed out of the benches. So over a 12-month period, we would incrementally replace all of our pebbles.
Okay.
Having said that, they're pretty cheap. They're like 10 cents a litre.
Absolutely. And they're pretty readily available too. You can get them any part of the world. We've worked on projects in regions where we thought, maybe some things we wouldn't be able to get here, but clay pebbles were there. And that's great, making sure that the global supply chain can, provide you with what you need is very important too. That's really interesting. So thank you very much for that tour. It really seems like there's very little human interaction with those crops. And as I'm sure you well know, that has huge benefits for the cost of operation. Your labor is reduced, and then on top of that, the biosecurity risk of having folks coming in and out of your farm all the time, is significantly reduced as well. Have you guys had any pest issues given how enclosed it is and the protocols that you're using?
We can proudly say in 8 years we have had no pest or disease pressure of any sort.
Wow, that's fantastic. That's really encouraging.
The only one that we had a close call with was Pythium, but we've got root zone temperature management now, which manages Pythium multiplication. So that's a non-issue. We've got wide roots. All good.
Well, it sounds like you guys have been doing this for many years and have figured out a lot of the issues with growing hydroponically and especially hydroponics indoors. So as far as the offerings of what vertical farm systems can provide to a user, do you guys provide everything, or are there some components that they have to go to other places for, or how does that work?
We provide the total growing system and through from planting to harvesting. We don't provide the building to put it in. We do not provide typically the packing equipment, because we found globally that varies on so much on a case-by-case basis of what local offtake agreements require. So we tend to stay out of that. And I'm qualifying that because several of our customers in Trinidad and Norway and other places have asked for us to supply automatic weighing and packaging equipment, which in many places is off-the-shelf equipment. It's not something we design or build. Yeah, we can source it and embed it into our system. Just lately, we've been working with a very large group in the UK. They've looked for a total cradle-to-the-grave product tracking, and we've put that in. There's a module in our system now where all of those rolling benches are RFID tagged as an individual bench, and the seed batch that's planted into them is logged, and then their entire life for the 28-day grow period is logged with all temperature and nutrient batches and everything that happens to them. And that goes right through into the packing area where that batch off that bench is then weighed and logged and batch numbered into the final packaging. So it's a complete stop-to-start tracking system that the retailers very much like, especially as some of the sections of the industry have been seeing E. coli outbreaks and such things. They need to have that traceability. We've never had any problem with that, obviously.
Yeah, absolutely. That's very encouraging to see that you guys are taking that the needs of these retailers so seriously and integrating those design considerations into the systems. That's great to hear. And God forbid if there's any quality control issues, you guys can go right back to that and find exactly which tray the problem was. So it's a really good insurance policy and way to kind of keep track of what came from where. And so you mentioned before that the system is currently designed for leafy greens, but you were looking at potentially doing other types of products in the future. Can you get into which what categories you guys have looked at and maybe some of the challenges around growing other crop categories?
Yes, certainly. We have been approached by universities, both in Australia and overseas, for growing of tissue culture crops and growing of DNA-specific pharmaceuticals. And because of our controlled environment is so sterile, it's ideal for pharmaceuticals, phytopharmaceuticals, or the tobacco crops that are being enzyme stimulated to grow DNA-targeted drugs. We're also being approached, obviously, by the medicinal cannabis people, the coconut palm seedling people.
Oh, interesting. Okay.
Yeah, there's a global demand immediate for 700 million coconut palms. I didn't realize what's going on in the coconut industry. The whole coconut products has had a huge in uptake with coconut water, coconut cream, coconut milk. However, coconut palms generally were planted after the Second World War as an economic stimulus, and nobody's been replanting. And they're reaching the end of their fruiting life. So now there's a huge push for 700 million coconut palms. So the opportunity to do that in our system has appealed to people. We've been looking at saffron. A group from India have come to us for saffron. We've been also working with protein, where we can do an insect protein that is for aquaculture and for ruminants. Also, ultimately, it is satisfactory. It's a 50% protein. It'll be good for human consumption.
Interesting.
It's a ground powder that would be an additive to meat products.
That's really fascinating. Did you mention you could grow insects in the system? It's an insect.
Totally.
Oh, wow.
Very much that same system you've just seen. And the insects we've been working with live off vegetable scraps is their sole diet. They don't require water, they don't require light, so we could actually dumb this system down to grow protein, really high-grade protein with omega-3, which is a critical input.
That's really fascinating.
So as well as that, I can diverge a little and I'll show you what's in the car park here. We've been working on animal feed, and this XF system here, which consists of 2 shipping containers. The 20-foot shipping container is a service module that contains computers and climate control and barley grain storage for 14 days. The 40-foot container is a fully automated growing system that outputs 2,000 pounds of barley grass every 24 hours. And that total labor input for this system is 8 minutes a day. And that is to push the button to unload it. Inside this system is all the growing and the LED lighting, and in the other cell is all the computers, and there's the discharge point down the far end for the delivery to the farmer each day. It's a new system, and we've already got systems going to Trinidad, and big inquiry coming out of Texas at the moment, which is very exciting for us.
That's fantastic. That's great to hear. It's really interesting that you guys are also focusing on these other crop categories. You know, the leafy greens industry is, you know, while it is worldwide, there certainly are opportunities in kind of these niche products that tend to yield higher revenue rates per unit of biomass grown, which is very attractive to folks that are running, you know, systems that are, you know, more precision oriented. And it helps to overcome the typically higher capital costs associated with that precision. But, you know, a higher quality, as global markets grow, you know, we're seeing middle classes grow in major population centers across the world. There's going to be an increase in demand for higher quality products. And it's great to see companies like yours meeting that demand with innovative design and new systems that can kind of serve those markets.
True. We found that the climate cell approach to the system totally transformed our business, where the energy we use for climate management is now a fraction of what it was when we were trying to grow in racks in an open warehouse. The actual power use just plummeted, and that has brought the profitability and the commercial viability up, but has also given us such a high level of biosecurity that is how we can expand into the proteins and into the other really sensitive crops like the pharmaceuticals.
Absolutely, yeah. I couldn't imagine growing out a whole farm of high quality pharmaceutical grade products and then having a pest knock it out. That would be such a tragedy. Can't happen. Yeah. So John, this was really great. Thank you so much for showing us your farm and answering all these very detailed questions about the way the system operates and the types of methodologies that you guys are including. This is all very exciting, and it's wonderful to see that not only are you guys addressing the leafy greens market, but also moving out into more niche products. You know, as the world grows and demands higher quality products and requires more specific pharmaceutical products, I think these core technologies are going to be really instrumental in meeting that demand. So thank you very much for joining us today. If you would like to, you know, provide some closing statements to our viewership, that would be really great.
Certainly. Our next step is the exciting one, where we are moving to the US. We're going to be fabricating and delivering in the US, and distributing and technical support from inside the US to our very large Canadian client and our already existing American clients who are getting ready for installations next year. So that's our excitement at the moment, is we get to bring this to North America.
Well, fantastic. We look forward to it. And I look forward to eating some greens from a vertical farm system farm.
It'll be a pleasure. Thank you very much, David.
Thank you very much, John. It was a pleasure. Thank you for joining us, and we look forward to meeting you in person.